Okay, so hi, my name is Cassandra Huber, and I'm a student at the University of Hawaii at Manoa, and I'm majoring in computer science, and I graduate in this upcoming spring in 2026. My project is on California County's annual AQI impacts on asthma emergency department rates. So the public health challenge. So some quick background information and motivation. Asthma currently affects around 3 million Californians. There's vulnerable populations disproportionately affected, and emergency visit costs healthcare system billions. And a personal interest, I have relatives in California with asthma. And then specifically, why California? Originally, I was planning on looking at counties in Hawaii, but ran into the issue of Hawaii having too few counties and lacks in diverse air quality. And then I tried counties all over the US and ran into the problems of trying to find asthma data for all states. But I found California was a better fit. So it has 58 counties with varying air quality and geographic diversity, robust health data collection, and if we can prove air quality directly impacts asthma rates, counties can justify investment in clear air initiatives. And this has a policy implications for 40 million residents. And briefly, what AQI is, it stands for Air Quality Index, and it's a 0 to 500 scale that condenses major pollutants like PM 2.5 and smog, which is ozone, and et cetera, and into a single number used for public health alerts. And then my research question, what is the relationship between annual air quality and asthma emergency department visit rates across California counties? And I hypothesized that counties with higher annual median AQI would have higher rates of asthma emergency department rate visits. And so my data set, I got my air quality data from the US EPA, and they were all CSVs and contained annual summary data for all counties in the US with reporting monitors, key fields, county year median AQI, and then some counties lacked monitors in certain years, and some counties lacked monitors altogether. And then I got my asthma data from Tracking California, which were Excel files and had annual data for all counties in California and California summary data. And then key fields were just county and age adjusted visits per 10,000 number of cases. And then it had NA for no visits reported in some rows, and then the year specified in the file name. So my data cleaning steps were standardized column names filtered to California counties only, renamed and added and reordered fields. And then I merged data sets with an inner join on county and year and dropped unnecessary columns and rows with missing AQI or asthma values. And then my results were 529 observations across 53 counties for the years 2013 to 2022. And here's a quick snippet of my cleaning process in Jupyter Notebooks for asthma data. And then, so my initial analysis, I looked at the more general relationship between median AQI and asthma ER visits. First, I calculated how closely the two variables are related, and the result was a very weak relationship with a value of 0.14. And then I ran a simple regression model to see how well the median AQI can explain asthma ER visits, and the result showed that only 1.2% of the chart changes in asthma rates can be explained by air quality levels, stressing a very weak connection. And then I plotted the data on a scatter plot with a trend line, and the plot shows no clear pattern confirming that there's almost no relationship between air quality and asthma rates. But thankfully, I didn't stop there and was guided towards another direction by one of my mentors, Luke, that likely these initial results are due to relationship between air quality and asthma is a lot more complex, and to look into other possible models. So why the simple analysis failed. I ignored key factors like county differences and year-to-year changes, which could affect asthma rates, and confounded the relationship by not accounting for other influencing variables, leading to weak or misleading results. And the solution, the multiple OLS regression model, it's a predictive model that uses historical asthma rates, AQI, county and year data to estimate how air quality and location-specific factors influence asthma rates over time. And here's the equation that is used, and it starts with a baseline of each county's usual asthma rates and adds a simple adjustments for the year and air quality. And it tweaks those adjustments until the predictions line up as closely as possible to the real data. And so model performance is extremely important. The strong model performance ensures reliable results for understanding the impact of air quality asthma rates. And so how accurate is this model? I plotted the model's prediction rate versus actual ED rate, and the red line is perfect prediction. As you can see, the points are very close to the diagonal line, meaning good predictions. And continued, here's a histogram of the prediction error, which is the residual distribution, and shows no bias, most errors cluster near zero, indicating the model isn't systematically over or under predicting. And also it had low RMSE and high R squared. So model results, since we can, since the performance was validated, we can accept the valid results. So here are the model statistics, or the key ones, and what do they tell us? So the model explains 87.6% of the variation in asthma rates, meaning air quality, along with other factors like location, differences in yearly changes play a significant role in affecting asthma rates. And for every 10-point rise in AQI, like good to moderate, asthma visits increased by 2 more cases per 10,000 people. And the p-value shows that the relationship between air quality and asthma rates is real and not just by chance. In conclusion, these statistics show that air quality, along other factors like time and location, do have a significant impact on asthma rates. And the location impacts suggest factors beyond air quality matter, like healthcare access and socioeconomic status, etc. And so my hypothesis is partially correct. And then more on the impact of time. The COVID-19 effect, stable rates from 2013 to 2019, followed by a dramatic drop in 2020 to 2021, and a gradual return to baseline in 2022 observed across all counties. And it reflects how pandemic-related disruptions led to changes in healthcare utilization, with fewer people seeking out hospital care. And my model successfully accounts for this disruption, demonstrating the importance of controlling for time and understanding these patterns. And then so to bring it all together, I packaged each of those exploratory charts, model diagnostics, and interactive filters into a Streamlit dashboard. So it has interactive filters for county and year, range, and COVID impact highlight. And it has all the data visualizations used in my presentation and an additional top 10 rankings by county. It also helps understand model predictions, and it supports the importance of being able to explore data without technical skills and focus on specific regions of interest. And its impact, I plan for it to allow for expanding data access for public health officials, policymakers, and advocates to drive informed decisions. And then reflections and next steps. So my key research takeaways were my hypothesis was partially confirmed. AQI does matter, but the relationship is also influenced by other factors like time and location. And proper statistical methods are essential for uncovering true relationships, and the adaptability and perseverance are crucial in data science projects. As I found, despite facing numerous challenges with data quality and processing issues and unexpected results, I discovered that approaching problems with a flexible mindset, exploring alternative methodologies can lead to innovative solutions. And then skills gained, interactive visualizations with alt-air plot, Lee Streamlit, and regression modeling and model validation. Some future work, add chloropleth map visualizations of asthma ED rates and AQI with GeoPandas. Just didn't have time. And then once more asthma data is available, to add more recent years to my data set, and then look into seeing the relationship between poverty levels and asthma ED rates. And then most importantly, troubleshooting with an issue in deploying my dashboard on Streamlit Cloud. I was trying to work on it with one of my mentors, Kai Funi, but I ran out of time, unfortunately. But I was able to get it working perfectly on localhost. And then I tried to get it working on Jetstream too, but didn't have time because I would have to switch some of my uh, code. And then call to action uses evidence to justify clean air investments while addressing broader health disparities. And then some big thanks, special big thanks to senior mentor Dr. Alex Dose, Luke Nelson, Connor Scholar, Gavin Wong, Sean Cleveland, and then training was provided by Kai Puni. And then and thanks to NSF CyberInfrastructure Summer Immersion Program and University of Hawaii and Hawaii Data Science Institute.
Awesome job. Thank you. Does anyone have any questions?